So here is another question on electric dipole parameters. So it is given that an electric dipole is placed at an angle of 60 degree with respect to an electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. And the dipole, it experiences a torque of 8 root 3 Newton meter. So if the length of the dipole is 4 centimeter, determine the magnitude of either charge on the dipole. Okay, so here, so it is given that we have an electric field okay, this is the electric field of magnitude equal to 4 into 10 to the power 5 Newton per coulomb or volt per meter, whatever unit you want to use, and we have a dipole, let's say like this. Okay, the dipole, it makes an angle of how much? 60 degree with respect to the electric field. So here the value of the charge on the dipole is not given. Okay, we have to determine the magnitude of the charge on the dipole. So here we know the given parameters. So what are the things which are given? First, the magnitude of electric field 4 into 10 to the power 5 Newton per coulomb. Then the torque acting on the electric dipole 8 root 3 Newton meter. Then the length of the dipole, which is equal to 4 centimeter, 4 into 10 to the power minus 2 meter. Always convert it into MKS units. Okay, and the angle of orientation of the dipole with respect to the electric field. So now we know the working formula here is that the torque acting on an electric dipole placed in an electric field at a certain angle is equal to P E sine theta, where P is the dipole moment, E is electric field, and theta is the angle of the electric dipole with respect to the electric field. P is equal to Q into 2A. So that implies tau is equal to 2AQ E sine theta. So if we want to determine the value of Q, okay, if we want to determine the value of Q, that is equal to, that implies Q is equal to tau by 2 AE sine theta. So that is equal to, substituting the values, 8 root 3 by 2A, which is equal to 4 into 10 to the power minus 2 into E, which is equal to 4 into 10 to the power 5, okay, and then sine 60 degree, which is equal to root 3 by 2. So when we make the calculations, the result is coming around root 3 by 2, it's cancelled, so it is coming around 1 into 10 to the power minus 3 coulomb, or equals to 1 millicoulomb. Okay, so this is the magnitude of either charge. So here it is minus 1 millicoulomb and here it is plus 1 millicoulomb on the charge on the electric dipole. Okay, so here is another question. So it is given that an electric dipole, it consists of two opposite charges of magnitude 1 by 3 into 10 to the power minus 7 coulomb, separated by 2 centimeters. The dipole is placed in an external field of 3 into 10 to the power 7 Newton per coulomb. What maximum torque does the electric field exert on the dipole? So here again, this question is on torque acting on the dipole placed in an electric field. So here the given parameters, the magnitude of charge, that is equal to 1 by 3 into 10 to the power minus 7 coulomb. This is the charge. The dipole length, or the separation distance, equals to 2 centimeters, which is equal to 2 into 10 to the power minus 2 meters. And the value of the electric field, that is equal to 3 into 10 to the power 7 Newton per coulomb. Now we know that the torque acting on an electric dipole in an electric field, that is equal to P E sine theta, where suppose this is the electric field and this is the dipole. Okay, and it makes an angle theta with respect to the electric field, the dipole axis. So this is the value of torque. Now here this torque will be maximum when sine theta will be maximum, this, which is the maximum value of sine theta, and that will happen when theta will be equal to 90 degree. So at theta is equal to 90 degree, there will be maximum torque acting on the dipole, and that value will be equal to tau is equal to Pe sine 90 degree. Sine 90 degree is 1, so that is equal to only Pe. Now P is the dipole moment. Okay, dipole moment P is equal to Q, either charge into dipole length, the separation distance, that is equal to 1 by 3 into 10 to the power minus 7 into 2 into 10 to the power minus 2. That is the dipole moment. And then Pe, the maximum torque, that is simply multiplied this with the electric field, 10 to the power minus 7 into 2 into 10 to the power minus 2 into 3 into 10 to the power 7. So here 3 gets cancelled, 10 to the power minus 7, 10 to the power 7, that goes, and we are only left with 2 into 10 to the power minus 2 Newton meter. Okay, 0.02 Newton meter, that is the maximum torque acting on the electric dipole. Okay, this also gets cancelled, so only we are left with this. Okay, so the maximum torque acting on the dipole, that is equal to 0.02 Newton